Hello, good morning to all. In this video, we continue with the interface protocol series, and for the sake of simplicity, we are taking the QSPI Flash Controller IP design in this part. So, this QSPI Flash Controller may require 2 or 3 videos. So, stay with me. So, before going to start with this QSPI protocol details, I just want to inform that we have some remaining parts STA and the CDC which need to be completed, and I will try to complete in shortly, so that our complete base is ready for the further discussion if anything is aligned with this topic STA and the CDC. So to cover this QSPI, we need at least 3 to 4 videos, so please stay with me, and I assume some basic about the SPI that you know, so that I can move forward, and you can refer the others SPI videos or data sheet for the specific or protocols, so that you can get the basic idea of SPI, so that we can move for the QSPI, and I will try to make it simple. Okay, so to write better code, actually we need to understand the basic of the SPI and QSPI, why we need QSPI, and what are the chips available for the QSPI, mainly for the flash memory controllers or flash memories, and from that we have to know the basic commands tables that given in the data sheets, and after that viewing that the command tables, we try to plan the RTL code. So more specifically, there are 3 or 4 types where we have to handle the read side command, write side command, and the device related commands. Okay, and at last whatever will be the left, we try to summarize at the end. Okay, so moving back to the basics, as we know, the SPI is nothing but the 4 wires protocol. First is chip select, second is clock, and then SISO. Okay, so as soon as the chip select goes low, we have to send the data on each clock of the S clock, and we have to put the serial data on SI pin, and at that time SO is in Z impedance state, as we can see. So it might be the command or data, it depends, and there will be the 2 modes. Mode 0 means in ideal condition S clock is low. If it is in mode 3, it means ideal condition clock is high. While considered to the that QSPI is nothing but a 6 wire protocol. These two are similar, chip select and clock, and the whatever the command and data we are sending on the 4 lines SIO from 0 to 3. So in basic way, QSPI is almost 4 times faster than the SPI, but it required more 2 pins for that transaction of the data or command. So in SPI, if we want to read the data from some address, so the first as we know, we have to send the command, then we have to send the address. Here the 24 bits is shown, but whatever the required size of this address depend on the what kind of memory you are accessing, 3 byte, 4 byte, maybe 5 byte. Okay, and whatever we are sending, it is on SI pin, and at the last of this address we are get the data from the SO pin. MSB is the first to come out. consequently we get the data 1 out, data 1, 2, 3 like that, and it depends how much chunks of data uh, that flash memory supports. For sake of simplicity, it is like 64, maybe 128 or 256 like that in one go. In dual mode, what actually it happens, the up to the address it is the same, but the data come out on the two pins SIO0 and SIO1. So it required only 4 clocks in place of the 8 clocks. So there will be some dummy clocks in between the data and the address. Okay, so we have to take care of that while designing the code. In 2IO read mode, actually what happened, only the command is in SPI mode, and the after that it goes to the dual mode. We have to also sending the address using the two pins SIO0 and SI1. There will be some configuration or dummy cycles, and then we get the data on these two lines. So it requires only 12 clocks in spite of the 24 clocks. So it is a little bit faster than the earlier one. So in SCORD, the simplicity is that we have to send the command, then address, then dummy cycles, and the data coming on the 4 lines from SIO0 to SIO3. So in this, 1 byte come out within the 2 clocks. So it is much faster, or we can say the 4 times faster than the SPI. So there is also W4 read command is there. In that, the difference is additionally we are sending the data and the address on the 4 lines, so it will reduce the 24 cycles to the 6 cycles only for the address. So in this way we can get the things in QSPI. Okay, so I just list out the what are the FPGA and R6 IPs are there for the specific platform and the vendors. So there are vendors like Xilinx, Altera, Lattice and Microchip provide the QSPI Accord SPI controller or IP. Okay, but it is not simple, it will be with the some AXI interface with that. Okay, so it depends what kind of access you want, like AXI or something else. So you need to check the datasheet of the particular IP. And as we know, the more dominant vendor in the IP field is Synopsys and Cadence. It can they have some IPs, SPI and QSPI host controller IPs for the ASIC purpose. So you can also check that. So the why we need this QSPI, actually it is four times faster, and also one additional thing is that we can execute the code from this flash, that is known as XIP. As we know, it is faster than this SPI, so we can use this for the system boot, and the system boot will be take less time. And as we know, with the fewer pins we can have the higher speed. For large capacity this can be used. Okay, because it is footprint and the size is very low or smaller in size, and has multiple options to integrate MCU, FPGA, ASIC. Okay, so I came across with the physical or IC or chip available part pins for this. So manufacturer is Micronix, Winbond, Micron. These are the part list MX, W, N series, and can be operated on the 1.8 volt or 3 volt. So these are the practical quad SPI chips available from these vendors or manufacturer. These are the features. More interestingly, the security registers, actually it is a very much important feature for this QSPI flash chip. When I was designing the secure boot project for the Lenovo and the HP, in that time I came across this kind of features, which is very required item for the secure boot purpose. Okay, so in a basic way there are some segment of the registers. Okay, I just go with the data sheet if it is there. Okay, I just okay, this kind of memory organization will be there. So we can we can say that these are the blocks, 64 size blocks, 32 4K, and this block of sectors we can actually protect against the write or program. So this concept called block lock and unlock. So nobody can directly write in these sectors because it is protected by the blocking arrangement that can be programmed through this QSPI protocols. So this can be used for the secure boot purpose. Okay, and also there are some other features with this QSPI, so you can just overview that. Okay, what I'm telling that this is just features. Okay, security features, block protection, there are some bits to protect particular segment of the memory, and there is also advanced sector protection functions. So while we are coding this, we will see in more detail about this, because this is the first video regarding QSPI. So we just try our best to have familiar with this kind of features, names and numbers. Okay, so that you just go through these numbers, data sheets, and check what are the details, what are the details about this flash QSPI. Okay, so moving back to this, so there is a more important part in the data sheet, because these are the available data sheets on the internet for the particular manufacturer, and you can refer the page number 15 and 22 for the command table. In general way you have to refer the complete data sheet, but more specifically what I am concerning, it is a command table. So we need to check that page number 15 what it look like. So obviously it is a memory, so there will be certain commands that can read, write, and having some erase functions, block, unblock functions. Okay, so take a simple one command. Let's say we want to read, it is a having the SPI and QSPI marking here, so this command refer for this SPI. Obviously we need to provide the address. There is no dummy cycles, and we have to we can get the data from the up to the infinity. I mean, to infinity means there is some certain size like 256 or 512 like that. Okay, so while considering the for read command, there will be this value as a command code. It can be operated in SPI and the QSPI. We have to give the address of the particular location, and it requires some dummy cycles, and it also provides the a bunch of data from that. So these kind of the tables we can refer for the designing of the QSPI controller flash controller IP. Okay, so again we check the different data sheet. This is for Winbond. So as we going for the read data, the code will be similar to this one. like this is 03. Here also the command is 03. We have to provide the 3 addresses. Okay, then dummy. In this case there is one dummy bytes, and after that we get the data from this. Okay, like that. So the when I read the different QSPI datasheet tables, so I found that the most of the tables are similar with the similar codes. Okay, so but there are some certain differences in the way that requires dummy cycles, and some has some other codes like that, but the structure will be the same. What I am to say, that structure will be the same. They have some certain commands here. Okay, it also has some commands. Okay, but the numbers may be the different for the command code, and maybe it has some dummy cycles like that. For the IP design we have to go in generalized way. So back to our discussion. So for the planning of the RTL code, actually we need a flash memory model actually. So you can get the flash memory models from the vendors. So what I have with me, actually I have the model for this Micronix, this number model. If you have any different model name, you can take that. Model is nothing but the some RTL code which is emulate that QSPI flash chip, so that you can have the simulation check with this, with the timing. This model also has some timing parameters, so we can have the exact replica of that particular chip, so we can test on the simulation basis. Okay, so that we can verify our the RTL code. So for that we need the model, and obviously we have to create the defined command list. This is under the first, and it looks like this. There is a command list, define name of the command and the value of that code, like that. So in general this will be depends on the what kind of that flash memory controller or IP you are designing for the particular targeted flash chip. So this command will be altered according to the requirement what you want to access. And the third point is we have to map the command to its required signals values. So it means if we want the read command to be mapped, so what are the required signals we have to provide or give to the controller. We have to give the code, then 3 addresses and the dummy cycle value. So what are the inputs? Command value, addresses, dummy cycle values, and the what number of data you want to pull from the memory. So these are the signals values we have to provide. We will see later on. And one last is a bit transfer receive module, which actually interface with the hardware or IP of the flash controller, which can interact with the pins like chip select, then S clock, then SIO0 to SIO3. So bit by bit we have to send the data and get the data from the actual model or actual chip. And last is test bench. So we try our best to go with the basic planning. Okay, and we try our best to have the first attempt for the read side in QSPI SPI dual QSPI 4IO etc, and second attempt we are trying to get the data related code like manufacturing ID, then some status like that, and last we try to get the right side code. The right side means programming to that particular location. It is a little bit difficult process, so to get this we need to understand the lock and unlock mechanism of this QSPI flash controllers, because it tend to be the secured process, so that no one can easily write that things. Okay, and it also based on the block, so block will be the 6432 like that. So if we go for the erase command for that, so the data will disappear, so that is why it is there. Okay, so while we are going for this, we obviously know much before this last, so I put this as a last, so that you can have much familiar with this process, and then we can get the right side. So the whatever I designed as a flash controller IP, that is QSPI Flash Controller IP. So the block diagram look like this. We have to command map module, which take the commands, addresses and the data length, which will map to the required signal. Okay, then command data transmit receive. So next block is command data transmit receive. Okay, which actually take the required signals and interconnect with the or interface with the actually flash controller chip or IP, whatever it may be. If it is ASIC, then it is IP from the specified vendors like Synopsys, then Cadence, or if you are dealing with the actual chip, then we can go for the Micronix, Winbond, etc. Okay, and for the check purpose, we are using the model of this memory, and model look like this kind of code actually. Okay, there are lots of code in this model, but we don't need anything on that. We just have the interface with this particular pins. Particular pins means that is our interface pins. These pins: S clock, chip select, SI, SO, WP, etc. Okay, so moving back to this, and we code each and everything here in the next video. So we will check. Please stay with me, and please subscribe, like and share, comment, and if you want any other things, you just send a mail and support me. Okay, thank you.